we'll start gradually. Then I think people who are coming will have time to come in. Anyway, I apologize for the people who turned up at 5 o'clock. I was here at 5 o'clock, but as there is less of a crowd today, we thought that we will wait some more minutes. So one of the things that I would have to rethink is whether I should go on repeating this lecture, because there's a lesser number of crowd. When I started when I took over this lecture about 4 years back, so I may have delivered about 8 lectures now, two lectures per year, maybe more than 4 years, maybe 5 years. There was a huge crowd here. So now every day either people have all passed after hearing this lecture, or people have got disinterested about the energy question or my lecture, or people are not interested about the energy question, I don't know, or less people are facing to the examination, whatever it is. My name is Samitha Midigaspe. I am working at the Ceylon Electricity Board as the Chief Engineer Renewable Energy, and I have more than 21 years experience in the organization as a engineer in generation stations, and also as the Chief Engineer and engineer in the generation planning branch, then in corporate strategy, and at present I am working in the renewable energy, Chief Engineer. But I am delivering this lecture on my personal capacity. So whatever I tell is my personal opinion. Of course, even my opinion, as I am working 24 hours to a semi-government organization, are within that framework. At the start of this lecture, what I would like, every day what I do is, okay, today there is about 3 something about 14 crowd. So who are working in the private sector and who are in the private sector? Okay. Government departments, direct government? Okay, only one. Semi-government, authorities, and okay. So evenly matched. And discipline-wise, are there any electrical people here? Okay, I thought so. Less of electrical people. Civil? Mechanical? I think I heard that your examination is very close, I mean relatively close. It's next week or something. Is it, or is it true? When is the exam? 3rd, okay. Anyway, not next week, then following week. No? Okay. So have you gone, I mean, looked at the energy infrastructure question? Any of you, have you seen it before? What do you think? Is it difficult? Because I am not making the paper. You know that the ISL rule is, who is delivering the lecture will not make the paper. So I don't know who make the paper, and also I don't know, but I have got some feedback which I will discuss regarding the question answering. But what I wonder is whether that question is difficult, or you don't like that. Are there any easy questions to answer? Anyway, so in this 2 hours, so I will have to go until 7:15. I apologize for that, but my duty is to deliver a 2-hour lecture. We started at 5:15. So I will go first do an overview of the country and power sector, and that will be the crux of my presentation also, that I will be giving you an importance of learning about, or having an understanding of, having a general understanding of things, of a general feeling of things. Then the historical development of the electricity or the electricity sector. Institutional overview, very important for us to know the institutions. Power system related networks, just an example or an understanding for you. Power generation and related costs, tariffs. What are the plans in the electric sector for the next 20 or the coming years? The key issues and the intermittency of renewable energy. So that is what I would touch upon, but some of the data stuff I will just go through, because I think this will be uploaded and you will be able to download it. So mainly the issues and some of the things that I would like you to understand and know. So that I would talk about. Overview of the country and power sector. If I move here, can you hear? Difficult. one of the major things as a professional or as an executive or as a senior person in an organization, or when you are representing your country or making plans for your country or for your organization, especially for engineers, is to have a general awareness, general understanding of whatever the sector and other sector, whatever the sector you are employed in, and also a general understanding, a macro picture of the thing. That is very important, because once we enter an organization, it may be a large organization, it may be a small organization. Sometimes we tend to be in the same job, or even there may be job rotation. But still, with regard to the engineering field or even other related fields, what happens is we tend to specialize on our job. That is very important for an engineer to be specialized on his craft, on his what he's supposed to do. But it is important because an engineer is different from a mathematician or somebody else, because the engineering is to change the environment, to deal with the nature. So you have to have an understanding of the environment, of the surrounding, and the macro picture. That is very important. What you are doing, how will it affect your organization, and how your organization will affect the country. Of course, to a world level, how your working is affect to a world level. Okay, if you have time, you can think about to that level also. But very important, how your organization, your work fits into the countries and the sectors picture, and also for you to have an understanding, general understanding of the sectors of the country, the economy, and the general engineering sectors, whether it is civil, electrical, mechanical, chemical, or IT. You should have some awareness, and that awareness comes mainly from, of course, from my generation, it is from reading, but for most of you, it will be from the web. For whatever source, you should be aware of the changing picture of the world, and that is very important when you are decision making. And also, as engineers or people who have dealt with mathematics, sometimes we may think the importance of numbers. Yes, the numbers are important, but on the other hand, it is very difficult for any of us to remember all these numbers. We know the value of pi to a certain degree of decimal points, that's of course, and also those formulas. But the ones all the formulas that we learned at the university, I don't think we can remember. But we have the ability to go and check. We have the knowledge where we should get and what sort of applications or formulas or programs or software that we have to apply. That is in our specialized jobs. In a similar way, when you are talking about a sector, when you are talking about a country, you should have some macro picture and an understanding of a ballpark figure. The ballpark figure is a literary word, a literary saying, to say a guessing figure or a number that you can remember, but that is true to some extent. For example, the population of Sri Lanka is available to, I think, 7 decimal places, so to exact number 21,000 to 21,362,000 something, but that we cannot remember. Of course, the director of the department of the population, what is that, the statistics department, he will know it, or the person in charge of that will know it definitely to some extent, but we don't have to know it. But of course, as engineers, as professionals in the country, we should be aware that our population is around 21 million. That is why I have put up some figures here. You cannot remember whether it is 21.2 or 21.3. When I was updating this, I saw that the last time also I had put, I remember that I was saying 21 million, but at that time it had been 20.7 or 20.9, something like that, which was in the last year's central bank report. But this time it is 21.273 or something like that. But still, for us it is 21 million. Last year, this year, 21 million. Or at least it is about 20 million. The country's population, why should we know about the country's population is 20 million? Because when you are doing something, because engineering and economics are very related. And when you are dealing with economics, the per capita, how much a person uses, how much a person spends. I mean, when you are producing something, how many people in the country? And out of that, okay, 20 million, half is just a figure, male, half female. So if you are producing some items that are shoes for the country, you know at least that there is a 50%, so there is 10 million market there. So if you are engineering something, okay, so that is this. So that is why we should have. And if you are comparing this, that is also important. Because in my sector, I have very much experience. I have very good experience. People coming from countries like China saying, when I say that there is a mini hydropower plant, is that so? And he is talking about a mini hydro plant. But it is only after talking about or discussing about half an hour that I realize for him mini hydro is 100 megawatt, 80 megawatt or something like that. For us, mini hydro is less than 10 megawatt. Even 100 kilowatts is mini hydro for us. For us, major hydro, the largest hydropower plant is 75 megawatts. The unit largest is 75 megawatts in Upper Kotmale. For China, it is even lower than mini hydro. So that is, so you have to know, you have to have an understanding of the level of what you are talking about. So that is why you should have an awareness. The population is 21 million. The area is 65,000 square kilometers. This area is 65,000 square kilometers. So I will take an example. When somebody says that there is so much of solar power available, and it is being, and you can, if you have that desert, almost you can power the entire world. True, but that desert is about 5 times the size of Sri Lanka. Sri Lanka is, so when somebody says that for 1 megawatt of solar you need about 1 acre, that is the rule of thumb. It is improving, but that is again a ballpark figure. So when you are talking, I know that there are similar things in your respective fields also. I will not try to give examples because I will fail, but there are similar things. So this awareness of general figures, of important figures in a sector, in a country. If you take a country, population, area, and of course those things like the area, of course I think most of us will remember, I don't know, the elder generation here will remember, because in those times when we were learning for general knowledge quiz or things like that at school, we learned by heart this Katapandas Tulsi Tisdeka. That will remain in our mind, I think, even up to this 3,332. But the population, it was maybe 15 million or I think 17 million at those times. But now it is 21 million. So that in India, it was 800 million some time ago, but I think now India has also passed 1 billion. So there is the comparison. When you are making a production, when you are comparing figures, when you have to compare rupees, the next one is GDP per capita, 3,800 something. So it is close to 4,000. Unfortunately, we have been close to 4,000 for about last 3 or 4 years. When I started the lecture, I think I remember one of the targets of the economy was to achieve $4,000 per person. This is the gross domestic product per capita, per person. And so this is close to 4,000, but we have not achieved, and according to the statistics that I also got to know, I mean, I saw it only yesterday when I was going through this presentation, when I was updating it, that we have, our GDP per capita has come down from relative to last year to this year, that is in 2016 compared to 2015, from something like 2,840 or something to 35. Anyway, we are close to 4,000. 4,000 is a big mark. So even if you don't remember or you don't know other figures, other countries, but you should have an awareness that our GDP is somewhere around 4,000. So when you compare with another country, or when you have that somebody says that your product is too expensive, you should compare, okay, or too cheap, or the cost of production is this much. You can compare. You don't know anything about that country, but you can Google it and see what is the gross domestic product of that, GDP per capita, because the total GDP does not give any value. Our GDP may be higher than a very small developed country, something like, okay, Liechtenstein or some kind of such a country. But it is the GDP per capita which is important. Of course, the total also has a weight, but you can compare. But that country, okay, you take on Tajikistan, what is the per capita? Ours is this much. So then we are in a close economic range. Then we have some ability. That is why we have this. We should have an awareness of the ballpark figures, awareness of ballpark figures for major figures in a sector. So we'll now come to the electricity and the energy sectors. In Sri Lanka, the electricity sector, we must have an understanding of what is the installed capacity, that is, how much power is available in the country. It is around 3000 megawatts. That is the dispatchable power. I will, in a further detail in a later slide, I will show you. So it is the installed capacity is something around 3000 megawatts. So that is something worthwhile for you also to remember. Not only me, not only an employee of CB, but not the general public, but professionals, especially people who are studying or getting their knowledge enhanced for the chart. Any engineer in the country should have some awareness about this. This is also not 3200. If you go to various CEB documents, it will be various numbers, because from day to day this differs, and there are machines which have the installed capacity, the planning capacity, the running capacity, those things differ, but it is somewhere around 3000. That we know. So that is, and the 3000 is the installed capacity. If you go through two lines, you see the peak demand. This is the highest recorded peak in the country. It is 2402, so it is something around 2500. So generally this is around 2100, 2200 when there is hot weather, when the temperature is high, atmosphere temperature is high. It is around 2200. Of course, this I think was recorded somewhere in March last year, and I am not sure whether in this year March, whether this was all these figures are for 2016 or the last available. I think almost all are 2016 figures. So if you take that figure, you have an understanding that okay, we have a 3000 capacity and 2500, below 2500 as of now to deliver. So there is a 500 difference. How will that happen, and what is the purpose of that? Those are details, but these are the important figures. The capacity mix is something like hydro 40%, thermal 60%. Energy mix, I hope you remember the difference between power and energy. This is something you will have to remind yourself. I know that all of you may have, with whatever the field, you would have done this power and energy in your introduction to electricity or theory of electricity. I can't remember whatever it is you are doing in part 1 or first year or whatever, but you will have to anyway have an quick go through of power and energy. Energy is power into time, that we all know. So energy is related to time, how long that you have been using it. Power is an instantaneous matter. So the energy mix, this is for 2016. 2015 this was thermal 40%, renewable 60%, close to 60% if I remember correctly. So how has that changed? That has changed because of the monsoon, the rain and wind, because this has about 5% wind, but in the previous year there was about 7% wind, and hydro it was almost 50%. So in 2015 renewables were close to 60%, but it had come down to 33% last year. So this one varies, but this is the power, this is the installed capacity mix. And if you take last year, though the recorded peak demand is somewhere around 2500, 2453, as I said, those are not figures that you should remember. 2500 is a good figure to remember. It's around 2500. That is why there are so many words, approximately, around, estimated. Yes, remember those things. Energy generation is in the region of 14,000. Energy sales is in the region of 13%. Sorry, 13,000. This is million units. A kilowatt hour, is what you call an electricity unit, that is metered in your electricity meter. So gigawatt hours is 1000 times. So that comes to 12,785 million units. So 12 billion units. So whatever. So anyway, gigawatt hours is coming from electricity units, 1000 into 1000. So once again, if you want to remember something in that range in the generation in the country, the generation is around 14,000, sales or the usage is 13,000. So about 1000 gigawatt hours is lost. What is this loss? You should remember this is basically the transmission and distribution loss or the power loss or the conductor loss, I squared R loss. That is a inevitable thing when you transfer power across conductors. Until you transfer power through a wireless method, this loss will be there, but you can always reduce it. So that is, now we come to an important one. Transmission and distribution losses are in the region of 9.6. Again, this is 10%, but still coming down. Last year it was 9.9. 2016 it is 9.6. So this is a very good figure. This is something we should be proud of as professionals, as a country, because it is not something that the CEB should only be proud of. People working in the CEB, but as well as policymakers, the country. The certain investments and the cost are borne by the people of the country. So that there have been developments in the networks, and these have resulted in these losses coming down. These losses were in the region of 20% in 2001. So that is every 1 unit out of 5 that was produced was lost in between. But that was not only transmission and distribution losses, there were other losses also. But you can think of that. Other than the power loss, when you have power generated at Victoria and distributed at Nugegod at your home. So what else? There is of course the I squared R loss throughout those 132, 220 and all those lines and down here. What else can be the loss? I didn't get you. I didn't hear you. Fraud, yes. That is commercial losses. We have a very nice name for it. The technical losses and the commercial losses. Basically pilfering, illegal tapping, illegal metering, all those things. But those things have really come down, and out of this 9.63, I would say almost more than around 9.5% or more than 9% definitely would be technical losses. So very 0.5 maybe in the region of commercial losses as of now. And another one is 99.3. So this is again something that the Sri Lankan policymakers decided at various levels, and that has resulted in 99.3% of our households electrified. Again, a very high figure if you compare with respect to per capita GDP. If you have a plot of per capita GDP and the percentage of electricity, so this we will not be in the average range, we will be in a special range, because people of this range will have a countries of this range of GDP would be in a lesser electrified level. So again, electrification almost 100%, technical losses 10%. So those two figures we can quote even when you are answering lectures. That is something that you can use, because in comparing with similar countries, whether South Asian or even Southeast Asia, those are the two regions that we can compare. Of course, the SAARC region as well as the Southeast Asia. Even in Southeast Asia, with these figures are not as good as maybe if you take a country like Thailand, maybe it may have, but it is competitive, these two figures. So those things are to be remembered. But again, not 9.63. You can't remember. When you are walking out of this room, you will forget this 0.63. But at least it is below 10. That is what is important. Even in all other things, even in your sphere of sector or sphere of work, you should have an understanding of this macro picture, where it is coming. So Sri Lanka is a country which has about 21 million people, 65,000 square kilometers. We have 3,000 odd capacity, and then requirement is about 2,500, and renewables and the thermals have a mix still. This thermal, whether it is thermal or renewable high, depends still on the weather pattern, and we have a less than 10% transmission T&D loss and almost 100% electrification level. This is a relatively low figure, but of course whether it is a low figure does not directly reflect anything. But of course industrialized nations as well as very developed nations, this is per capita electricity consumption, total electricity usage divided by the population. So how much electricity one person uses. If you compare with very developed countries or industrialized countries, these figures are in the region of 5,000, 4,000, those things. And even countries like India, Pakistan also, I think, to some extent, definitely India has a higher per capita consumption of electricity, even though their electrification levels are much less than ours. So they are there because this comparison is a little difficult, but one of the main reasons is these countries have more energy intensive or electricity incentive industries. They use a lot of because they have of course we know that India has a very big industrial base, so that is why they have more electricity per person being used, even though their domestic usage is very much less. So that is the macro picture of our country and our power sector. The capacity, that again these are approximate figures, these things are changing day by day. When I was going through that this yesterday or today, I can't remember, yes I think yesterday, this temporary number and this emergency number I wanted to pick up. This is emergency diesel generators that CEB hired for a short term. The contract had expired the day before yesterday of some plant, so I did not have a number. There are some still running, but I could not find out the exact number. The 60 megawatts of were purchased on short-term basis. So this is not there at the moment. So that is why I think it is changing. So once again, how has this now here from that 3,200 or 3,000, I have come to another approximate number 3,225, but that you cannot remember. So thermal, there is about 1,800 total. Sorry, hydro 1,300. So again, you can remember this as there is about 2,000 and 1,000 plus hydro. That is what we can remember. This is capacity wise, you have to remember. So that is how. Now out of this, the important another figure is to remember is 800. This is a 900 megawatt coal power plant in Putlam, the Lakviche plant. What I have given is the net figure 825, because that is what we can get. The internal usage is, each plant has about 25 megawatts of auxiliary power usage, internal usage, house supply. So these are the figures that of the sector if you want the disaggregated figures. But here again, that you should remember that the capacity of thermal is higher, the installed capacity of thermal is higher, and the hydro is this much. And what is this? This is NCR, non-conventional renewable energy. That is a term that is used only maybe in Sri Lanka. Other countries use other new renewable energy, new energy. It's similar thing. It is renewable energy other than major hydro, because people wanted to, because of certain interest, I would not go into detail, because of this climate change talks, carbon issues, people didn't want to put in major hydro. Of course, hydro is a renewable source, but this now in the international arena and everything, when we are talking about how much NCR is, CB, Sri Lanka is having around 10%, 11%. That is how people are talking about. And we have a target also, the energy policy had a target of 10% by 2016, which was achieved. And the government policy is a 20% of NCRE by 2020. All those 20 figures, no. But unfortunately, what everyone has forgotten is, we were 100% renewable, and other than this new renewable energy, we have major hydro that is renewable. Because of calculating these carbon emissions and all those, certain countries, developed countries did not have major hydro, some had major hydro, so they did not want to put major hydro there, and everybody now is putting out major hydro out of this renewable thinking. And when we are talking also with others, they say, you have 10% only, no? But renewables, no, we have, year before we had 60% from renewables. Of course, some was major hydro, some are from new renewables and this non-conventional renewables, and this is increasing day by day. And out of that, this is what I have said here is non-dispatchable and dispatchable means is that when in Sri Lanka the power system is controlled by a single utility, the transmission license is CEB, and CEB's system operations are done by the system control center. So when the system control, as you know, when the system control center wants a power plant to run, when there is a load change, you know that when I switch on this light here, if it is an AC light, you need that power to come from a generator instantly. You cannot store AC. That is still a fundamental, and storage, energy storage, especially electrical energy, is still not, even though we know that there is lot of developments coming, but at a reasonable cost level, it is still not available. So we have to store it as fuel. That is the issue. So dispatchable plants are where the fuel storage is available, and when the system operator wants 10 megawatts to be done immediately or increased immediately, increasing the fuel amount, you can get it. So there you need either storage hydro or another thermal source. This non-dispatchable is whatever is available, we have to run. It is dependent on the source because the source is variable, and with when the source is variable, because you cannot store, the storage has to be, because they do not have storage. Once or when the storage is available, this and this would, so then that day we can say that this 500 also to be added to this 3000 and say that we have a 3500 megawatt capacity. You should not in electrical terms add this capacity and this, because they serve two purposes, and at certain times these are not available. Of course these also are not available certain times, but that is at known times, you know beforehand. But about this time, these things you know beforehand, but not exactly. And also, as there is no storage, even of what is available, you cannot have it when you want it. So that is the difference. This is just an overview of the generation shares for you to remember or to have an understanding. This is in three colors. Can you? There is a difference in here, red and sort of a brown. Can you see it? I find it difficult to see. So that red one is coal, this is oil, and this is hydro, and this is wind and renewable. As you would see, this oil and hydro, thermal and hydro percentage has varied. So this is percentage, not the exact, not the absolute figures. This is the percentage, and you would see this wind and NCRE. So this is the new. You don't have to say it is wind and NCRE. We can say it is NCRE. So this has changed. In 2015, you see that we have had a good percentage of wind, but not here. Similar to hydro. So there the percentage is almost 30. Here, I think I made a mistake. This is almost close to 50, not 60. 2015. We had 60% in 2012. So these are the good years for CEB. If you plot the CEB's losses also, it will be lesser mostly in this year. So there may have been some operational profit in the years when there was the renewable percentage is high. And you would see that the coal from 2010, it has taken up a higher amount now. This is coal, I'm sorry. This is oil. So coal has increased to 2010, there was almost nothing. In 2011, the first plant was commissioned, and in 2014, the second, 15, both plants, second and third, and after that, so around this 34% would be coming from coal. And the much maligned, or much talked about Noracholi plant, which is supposed to be broken down all the time and is a very huge catastrophe, is delivering 35% of our energy at the lowest cost thermal plant, and even thermal plant, and even with compared to renewables, other than mini hydro, which has run for 15 years. The unfortunate tragedy, coal plant, which the Chinese have offered us, is fortunately delivering 35% energy. But that does not mean that it's a very good plant which is running at 100% plant factor without any troubles. It is giving trouble, it has trouble, but it is delivering energy. Of course, the availability is coming down. So when we were beggars, we did not, beggars are not choosers. When we had the opportunity to have a Japanese plant, of course, our policymakers decided not to have coal back into year 2000. And in 2006, there was nobody else to give us. And the governments at that time, two presidents decided, one president decided, okay, we should implement it. And the next one decided, enthusiastically implemented it. And because of that, we have that plant. And it has its faults because it's different. It is not one of the best plants in the world. But anyway, it has delivered 35%, around 35% of the 34% energy of the country's requirement last year, electrical requirement. Here again, this is last year's figures. Just this is to give you. Again, here it is hydro, renewable. So this is how over the years, the last 6 years, it has changed. Last 7 years, you would see that as percentage wise, generally the thermal percentage is generally increasing, but with the renewables, because this major hydro portion capacity wise will be the same. There will be only few more plants to come in. So almost this is thermal made up of coal, CB oil and IPP oil. IPP is the independent power producer, that is private sector. So this is the renewable part for the last year. 25% from major hydro, 5% from mini hydro, 2% from wind, and this is less than around 1% from the other sources, mainly biomass and some solar last year. So this is, once again, you must remember that this is a changing picture. This was quite different to if you take 2015. Okay. Now I will just touch on a few things. Something that when we are learning about the electricity sector, this is also an important picture. In the electricity sector, as I said previously, we have to supply electricity when we want it. The utility has to supply electricity when you want it. When you switch on your fan, some generator has to increase its output. Similarly, when hundreds of people do something which affects the electricity system where they want more electricity, the new generator may be required to start up in a short time. So that is why this curve is important. This is our demand curve. You would see that this has not changed for a long time. Here, this is starting from 2009, this is 2016. Only thing is this, the difference between these peaks has here around 2009, there was about this much of a difference, but now only this. So the day peak has increased to some extent. We call it the morning peak, the day peak and the night peak. So this difference is coming slowly, becoming less, but still this is a very set pattern which we have had for a long time, and there is a prediction that it may change to in about 20 or 10 years time to some extent to having a day peak, but still this is what we are serving. So you would see that this is midnight, this is the 24 hours of the day at every half an hour intervals, and this is the capacity. So this was done some time ago, so that is why it is below 2000, but still the pattern is the same. So you start up in the morning, you wake up in the morning, switch on the first the bathroom light, then the kitchen, and one by one the iron is switched on, and the washing machine is maybe, and especially the iron and the rice cooker. Those are essentially put on, and then after some time when the kids are waking up, maybe the living room lights, like that. So at 6 o'clock, of course, lights are coming on and you are leaving, this comes down. And we all come to our offices, and before we come maybe the office other workers or maybe ourselves, we will be switching on our lights, then the computers, then the ACs, and the factories and all other things that we are working. So we are working on, and of course at around lunch there is a small blimp or a decrease, because some people, maybe some energy conscious people, may be switching off their computer or the light when they are going out for lunch. And of course in industry, if they are having a lunch hour, they will be shutting down the machines. Anyway, it is almost flat, and at 4:30 we are leaving our office, switching off the lights, and it's coming down, and it will come down right down to here if it was normal. But of course, when some of us are leaving the office, some have already reached house. So by 6 o'clock we are at home, and we start switching on our lights one by one. The living room, then the garden, then maybe the gate, then the toilets, the washing machine may be switched on, cookers, and the television. So for 3 hours, from 6:30 to 9:30, we are having the peak of the country. At this time it was about from 1000 to 1900, almost 70% increase in half an hour, from 6:30 to 7:30. Within 1 hour, a 70% increase in from the day peak relative. So you should start up machines and load them to this level. So that is the energy infrastructure needed in the country to suit this. We should have machines to supply this, which is 24 hours. This does not take. There is the intermittent, the middle level, where most of the time this will be working, but at different loads. And then there is the requirement of 3 hours, where it's a ramping and coming down. And of course, this is the important part of the night. Light is needed when light is not there, especially in the night. So we will all be thinking that this is the very useful light. We are making very useful usage of this, because our kids are learning and all that. But I am doubtful about it, because most of the energy at this time would be used for watching the TV and maybe the air conditioning at that time. So watching Run the Pair and all those things. So whether that is, of course, that has commercial value, commercial input, then the gross domestic product will increase because of those things also. But I don't know how that is the economic output of that. Anyway, this is the pattern of the electricity demand in Sri Lanka, and we have to cater to that. All the electricity infrastructure in the country is constructed or implemented or operated to supply this. And as I said, this has not had a major change from, this was the same 20 years ago when I joined also. Only thing is, this is going up with the increase in demand. And this is the 2016 figure. It is still there, but only thing is, as I said, day peak and night peak are coming a little bit close. If you take here, it is 1500 to 2000, maybe a 25% increase in 2009. But now from around 2100 to 2500, so 400, 20% now. So it is coming close with development. That is mainly because there is one school of thought is this is coming, the daytime energy usage is high because there is more commercial work, more industrial. Yes, that is true, and the peak is still only the lighting and TV. On the other hand, there is a huge increase in use of air conditioning. So that is also affecting this daytime demand. Of course, if we are not at home, the air conditioner may not be working, but still some people are there at home, so there is a usage. The historical development, of course, these are things you don't have to remember or anything, but when you are talking about the infrastructure, energy infrastructure, we should have some awareness of how this has developed. It was in 1882, this is just a historical issue, when in Sri Lanka electricity was first seen from the Helios ship. First building illumination was in the Bristol Hotel in billiard room in 1895. And in 1912 there was a small hydropower plant built in Blackpool, Norelia. I will come to that. Thermal power plants in the cities, that is for by the municipal councils or maybe the local authority bodies or by private parties contracting to the municipal bodies. These diesel generator stations were established in places like outside Colombo, also Negombo, Palliagoda, suburb towns. And in 1918, something very important was presented. That is, engineer DJ Vimala Surendra presented his famous paper. I think all of you would knows about engineer Vimala Surendra's paper on hydroelectricity. And we know that he is the father of hydroelectricity in Sri Lanka and one of the finest engineers we produce, not only in electrical engineering but in mechanical, civil, in many fields. But I would like to focus your attention onto his paper, the name of his paper. It is Economics of Hydropower Utilization. That is one of the most important things. Engineering and economics, as I said, if you look at from a macro level, if you look from a higher level, or if you look at it in a broad view, you cannot disentangle economics and engineering, because they come together. And because engineer Vimala Surendra was a great engineer, he had talked about hydroelectricity, which is an engineering aspect, which has civil, mechanical and electrical aspects, and he has coordinated it, or he has included economics into it. And if you read that paper, it is available, I think, in the web as well as in the ISL library. I have read through it once and glanced through it several times. You would see is that it is more economics than engineering, because at a higher level, engineering, even though is the core, economics has a more amount of whether in a paper or when you are working on something. But economics not finance, not the value or selling price or something. It is the economics. In that he has talked about the availability of a resource, that is hydroelectricity, hydropower, or water, which can be converted to hydroelectricity. And then he has seen that at that time there was no such demand in the country. But so he had seen that there is a huge potential of hydropower, and he wanted, and he had found out, and he has analyzed what you could do with it. One of the things he has said was that because at that time we had about, I think, about the 75% or 80% of the railway lines that we have now, or maybe 100%. So he had suggested or proposed, not only suggested, that is what an engineer, he has gone and done the calculation, compared, and he has suggested converting the trains into electricity power, so the electric to introduction of electric trains. He has talked in his, he analyzed and presented his views or proposed in the 1918. This is 2018 next year, and 100 years we are, I think, still talking about it, and I think there are feasibility studies going on. There have been many studies. I have also been part of them, some of them. We all, some of you maybe have talked about it or studied about it or have been part about it, and may have supporting or opposing views, but still 100 years we will celebrate Engineer Vimala Surendra's paper of 100 years next year. One thing is, to a great extent, we have been able to utilize the hydropower potential that he foresaw or he anticipated in that paper. Not only that, in that paper, use of electricity he has also proposed and analyzed, because he had seen that Sri Lanka is an agriculture country, because the people are used for agriculture, and he had seen that the necessity of fertilizers to encounter the economic changes and the changes in the ways of the living conditions of the people, and how this production of food, the food revolution, of course there may be other schools of thought about the food revolution and how use of fertilizers, but that is another concern. But with regard to that also, he proposed putting up fertilizer plants using this electricity, using resources available in Sri Lanka, and also at that time also we have had certain amount of foreign exchange used for fertilizer to lessen that. So that are two major things that he had proposed in his paper, other than just hydropower. So that is the importance, and he has done calculations, presented the economic figures. That is why Engineer Vimala Surendra, I would say, is a great engineer. He's a pioneer, not because only because of his for the use of hydropower, but its uses, how it can be used, and he has analyzed it and presented the paper. And of course, these are the other developments that that took place in 1950. The Lakshapana, the first major hydropower plant, was established, and in 1962, the major, the large-scale first thermal power plants. Of course, until Lakshapana was implemented, we were served by thermal power. But the major thermal power plant was in 1962, the large scale one, the Kalanithissa steam power plant of 50 megawatts. And the first Mahavali power plant using the Mahavali river water was in 1976 under the 30-year Mahavali program. You would know that this was changed to accelerated program by the government which came into power in 1977. And the Victoria was the first power plant to come up under the accelerated Mahavali program. And the first, of course, there were private power parties which supplied electricity some time back in the early 20th century, but after that it was electricity board and the municipalities which were doing it. And by in 1996 again and 97, with policy changes, there came the opportunity for the private sector. So mini hydro or the renewable energy, the first plants were connected under a special standard power purchase agreement. I will talk about it later. And in 97, the first IPP, that is a thermal power plant. The first combined cycle on 2002, and 2011, the first coal power plant. So those are the major events. Of course, the other detailed ones are there. But what we have to see is that the gradual development, how it has taken place. This is the hydrothermal historical share, how this has developed from maybe 1996. You would see that there is almost out of how much? Yes, out of 4,000, not almost 3,000 has come from hydropower. In 1990, I think this was almost 100%. Even though we had thermals, the thermals were only for when for years where hydro was not available. But the hydro potential in the country has been utilized to a great extent now. That is why you would see that this is relatively a straight line. When there is higher rainfall, this is increasing. So whatever the gap, we are now filling up with hydropower. There has been self-generation, and of course thermal power, which is coal and oil, and this is renewable energy or the new renewable energy. The hydro potential in the country, the large scale hydro potential and even the lower scale mini hydros have been utilized to a great extent, except for the ones which for environmental reasons we may have not utilized, and some few plants that are under construction or under plan. Okay. So up to now, we have talked about the sector, the importance. That is what my main message of this lecture is, to have some awareness of the macro picture of the organization of the sector, and some ballpark figures, some figures that you would make sense of what is happening. Because you would see in newspapers especially, you would see a huge half-page advertisement or even a news item about a certain power plant being implemented, and opposite to it there will be another party saying or somebody saying that there is a power crisis, so there is a power shortage in the country. So when you have these two, you tend to think that this is also the power crisis, so the issue is one column, the paper article about the new power plant is half a page. So because of that, so this must be bring some relief to the country. But if you go through the numbers, you will see that what is been this huge development is about for a maybe 10 megawatt or a 5 megawatt power plant. But the crisis, somebody is talking, okay, we are not having a 300 megawatt plant was cancelled. This plant was not going to be there. The deficit is going to be about 400 megawatts, so something like that would be in that small article. So there you would have some understanding, or even without that one, if you see that this is a 10 megawatt power plant or even a 1 megawatt power plant that somebody wanted to put a nice picture. Of course, they have a value, but I'm not disparaging them. But you have to have an understanding of their place, requirement, and the total macro picture. That is simple. So, what could be its benefit? A 10 megawatt plant will have a certain benefit that if it is a renewable plant, yes, in the long run, it will have a positive effect to the country's economy vis-a-vis foreign exchange. But will it solve the capacity crisis? It may not, because the renewable, if it's a solar power, will not be available in the night. If it's wind in Putlam, it will not be available in January and February when we don't have hydropower. So that depends. If it is biomass, it will be totally dependent on having a good supply of dedicated biomass plants, biomass grown, and that is also affected by weather, whether you will have. So those are the things now that because of that figures, values of ballpark figures, they import. And then I talked to you about the country's the capacity and also the demand pattern of the country, which is important for us to understand that we need varying types of generators, and that our demand is increasing due to various things, and also the load pattern. And now I will touch upon okay, I think I will talk about this also first. Up to now, please remind that I skipped two slides that I have to go back after this. After just two more slides. So this is another thing, a backdrop picture that you should have some understanding. We are talking about the energy sector, the energy infrastructure. I know that all of us have learned this type of thing for some at some level, at least in the first year at university or whatever the post that you did. What I am saying is here, this is an industry or a sector or engineering sector or an engineering industry. Then we should have an awareness of from where it starts, where it ends, the process. If it's a production, you should have an awareness of from where the input is coming, how it is sourced, how it is processed, how the output is taken, and how it is sold, like that. For you to put figures, to put your economics, put your finances, you should have an awareness of process. If you have a schematic diagram in your mind of how this thing happens, it's very easy for you to build upon that. So another thing I would like you is to have some kind of a schematic diagram of the electricity sector. Even the general manager of CB or even the system control centers operators, now because it's a complex system, do not remember by heart all the transmission lines in the country. That you cannot. And even the country's transmission lines, I don't want to remember. So nobody should. But we should have an awareness of a generic system, how this happens. That is what I am saying. So this is a typical arrangement of a power transmission network. So think of electricity as some kind of a good, which is produced at one place and sold to a person at another place. Parippu again. So Parippu may be or right price. It may be produced somewhere and transported. Remember. So because it's a utility, you have to produce it, transport it, and again retransport it and hand over to the user. Think of it as like that. I think water, electricity, telecommunication to some extent have certain similar this thing, and any good transport, any produce. A production process may be a little different, but still you can have a schematic or a single diagram of the process. So this is the process. So you generate electricity. So this is the production. Think of this as maybe as your rice field or the import harbour for Parippu, for Dal, but for electricity it's the generation. It could be a hydro generator, it could be a thermal generator. And once it's generated, there is a transformer. I think you would remember from your electricity basics that we generate at a relative low voltage and increase the voltage, because at higher voltages the losses are less. Because the current is less. I don't want to go to theory, but that is the basic theory. If you have good big lorries to transport, rather than having a lot of lorries, then it is easier to transport. Maybe the losses will be less to some extent. Because when you are putting into the lorry and taking over or like that, or things that got stuck in the body of the lorry, if they have so many lorries, it will be higher. So this is something like that. So your major transport, this is the major road. In that you put it, the road, you build it large, so that a large amount of production can flow through it. So this is the 220 kV. In Sri Lanka there is the 220 kV, the 220,000 volt lines, transmission lines, and the 132,000 volt lines. The 66 kV is now no longer in use. It's almost even the physical infrastructure has been removed, the line. So we have operating transmission voltages only of 220 kV and 132 kV. This may be something for you to remember. So in the 220 kV, we will transport. So this is a long transmission line. We are transporting electricity from one transmission station, maybe from Potmalay to Biyagam, or from some other station. Maybe this is Pannipidiya, whatever. So this is a grid substation which does not have distribution, but again it is we can call it a sort of a store or a transferring place. It has lines coming from here and going there. I have drawn this as a sort of a radial network, but it may not be a radial network now. Now there it is more of a circular network. There are connections from here to here like that. So sorry, from here to here or other. But this is a simple schematic diagram. So the electricity flows in this major line or the expressway in heavy transport, bulk transport, and from here it may come down to 132 kV. And this one may be connected directly to 132 kV. This is through 220 kV. So the transformer, so this is a grid substation, and through this it comes to a substation which has distribution. So we may take this as our major storing center, or maybe this is the in the Peta, the second cross street or the fourth cross street, where you have this major, or if it is rice, this may be Marada Gamula or Polonnaru. If this was vegetable, it may be Dambulla. So you bring in large lorries up to here, at the 132 kV network, and here there is the medium voltage distribution, which is generally 33 kV in the CB network and 11 kV in the LECO network. So in the grid substation, so you bring it down to a lower voltage, medium voltage, and at medium voltage you may supply bulk consumers, or you may go to, so this is your Kadek, the village shop near you, or maybe Kargils. So this is 33 kV transformed into 400. Then you have the customers. This is the doorstep, close to your doorstep. This is brought down to lower voltages for your usage. So it's starting from 220, it may have come down to 132, or this may have come directly from 132, but anyway these generating voltages would be 11, 10 or maximum 20. But it has now come back to 33, so this is the wholesale market. This is 33 kV, this may be to LECO, because 33 kV will bring it down to 11 kV, there will be bulk consumers, or going to LECO, and LECO will have something like similar to this. So this is the major network. Like in a transport system, you have bulk transport carriers, and then you have the wholesale shop and the small wholesale shop, and then the retail shop. Similarly, there is the wholesale shop and the retail shop, and maybe these are transferring centers, something like that, transshipment if you take container sense. So this is the typical and the conventional power system, and all the protection we need, the power system operations, all were planned under that. But this was disrupted to some extent with the coming of the small power or the renewables, because they are scattered in the country and also in small capacities. They are connected at 33 kV level. Now this is different. They are connected at 33, mostly at 33 kV level, because to connect at 132 kV level you need a large amount of power, otherwise the losses will be higher, and also you have to transport it to a long length because the grid substations are few. But the 33 kV level you can. So from the mini hydropower or the wind power plant or the solar power plant, we connect to at 33 kV level to the system, and here it does not go through the transmission network. It will go directly to through the 33 kV network. Not all the time, but most of the time it may be within the village itself or within the town itself. It may not go to the grid substation. This whole generation may be distributed from the 33 kV bus to these consumers. So then, but when it is not available, when this is not available, they should be able to bring power from this end also. So previously protection and all the operations were set up for power coming from this side only, but now you should be able to handle power coming from this transformer or from this mini hydro. And also if there is excess power from this side, if you take for example, when if there is a heavy rain in the midnight, after midnight, of course there may be no demand from here, so this power will have to be transferred through this. So then the protection, the equipment here has to be able to cater to this also. So this is a difference from the conventional power systems. So that is why maybe utilities do not have certain reservations about connecting the small power. One thing is its intermittency, the other one is the difficulty and the problems of the power system operations protections. But that does not mean that you are not going to connect or that they should not be connected. But what we should understand is that there are issues of, because these power systems are set up in such a way in conventional times, and anything that is adding may have added in costs. So this is the process, transport process from one end to the other. For just any other system or industry or utility, electricity also has that, where it is produced and where it is consumed by. It may be consumed in bulk, may be consumed in retail price. Of course, this is the Mahavali complex, that is from the Mahavali water. This is the Laksapana, Valave, the three major waterways we are using. Maybe people in the irrigation and Mahavali would know this better than us. So as we are talking about the present transmission network, I will touch on that also. This is the present transmission network. There is one major error here. Okay. What is in purple? Yes, to me it is purple. Purple is the 220 kV network. What is in green is the 132 kV network. So basically only the the transmission network is here. So the Colombo area, which is congested, is given in this map. So basically what you can see is that in this area and in this area there is a congestion of grid substations. The other areas the lines are less. I mean, this is if you take the GDP of the country by province or district wise, you would see the concentration here. If you take the population, it would be concentrated here. So electricity also similar. So that is the way electricity is supplied where demand is, and the generation is here. Here the more concentration is because of the hydropower generation. Lakshapana is this side, Mahavali is this side, and there is the radial networks combining, but to either from the western province, that is to the load centers, or the thermal plants, or from hydropower plants. So that is how these lines are at present. One is missing, there is a 220 line connecting this. So there is a 220 ring at present. This is Biyagama, this is Kalnitissa, and this is Puttala, Lakvijay. This is Pandipiti, I think. So there is a 220 ring like this, and the others are 132. So this is the present network. This 220 is operating at present from Anuradhapura to Puttala. The future network I will touch when I am talking about the future. Okay, now I did miss, oh sorry. Okay, something boring. Oh, I know that the lecture was boring up to now also to some extent, but this is something that we have, once again, something that is important. This is the macro picture. We said that we should have an understanding of the macro picture. So if we are talking about cricket, we should know who are the important parties in cricket. If we are playing a cricket match, we should know that there are two parties important. The two parties who are playing, Team A and Team B, maybe Sri Lanka and India if you take today's context, present context. And of course, there is another party, the umpires. Then there is the ICC. ICC is represented by the referee. He is also there, the match referee. Then there are the umpires. Then the groundsman is also there, but we'd say that he's not in, he's represented by, okay, the cricket board, who is the host. So under the ICC rules, the host also has certain duties and responsibilities and maybe benefits or rights. And also when you take the two parties, that also have certain officials, which are officials. That is the team manager. So under ICC rules, I think the manager is mentioned on those rules. And then there is the captain, then the wicket keeper. So that is in play. So wicket keeper has certain, because the wicket keeper can wear the pads. So that is mentioned in the ICC rules. The bowler cannot wear pads. So that is like that. There are the players or the parties in a sector, in a game or in anything, and also the rest, and in those parties also there are specific persons and also the rules that are governing. So that we have to have an understanding and what are those organizations or organizations and the institutions, and what are the rules that sort of covers this sector, the electricity sector. So the major organization is Ministry of Power and Renewable Energy. Is today's as present, that is the name, the Ministry of Power, which represents the government. So the government, and when you say it represents the government, who does it represent? It represents the people, because it is the sector's owners, the owners of this resource, of the power sector. The people are represented by their representatives in the parliament, and also the parliament appoints the executives and the legislators. So the Ministry of Power and Renewable Energy is there to set the policies. Fund control also is to some extent by the Ministry of Power and Energy. Then CEB, which is a government-owned or a government-owned board, a semi-government organization, it has the transmission monopoly. The transmission license is the only transmission license in the country, and hydro and thermal generation as well as distribution. Then there are government-owned companies. This is not in any importance or anything, but as there is no specific importance in the way that this is listed, because hierarchy. It's not in a hierarchy, and the hierarchy may be in different ways. You can have different hierarchies. Then there are the government-owned companies, the LECO, which is a distribution company specifically owned by government and CEB. LTL, LTL Holdings, transformer production was its original start, but it has diverted into many other things like EPC contracting or power generation. Then IPP. What does IPP mean? IPP are, in Sri Lanka sense, IPP is generally for thermal power producers, the independent power producers who sell to CEB on long-term take-or-pay specific contracts. That means these the IPPs, the independent power producers, have specific contracts for them, depending on their capacity, depending on their investment, depending on their return on the tender, because these thermal power plants have been are different contracts. If you take the different, for example, there is the AES Kalitisa, which is named Sojitsu today, and then there's the Asia Power, two companies which are in operation. I will name them. I can name them. So they came in different tenders, and also they have different technologies and also different fuels. So they will have different contracts, unique contracts for them. Independent power producers have unique contracts, and they have and for their investment is secured in a certain way by the take-or-pay contracts. That is, if they make their plants available, their capital investment with the return will be repaid. It does not matter according to the contracts, because the contracts have two types of payments. I will not go into detail, but the contracts are made in such a way that their energy production is not linked to their profits. As you would see that you saw that Sri Lanka's thermal production is dependent on the weather. So with the weather pattern changing, the requirement of thermal changes, and because of that, because the demand projection is a sort of a statistical issue, it is a projection, you cannot be certain about it, because we have a sort of a centralized power purchase system, not a market, we have had to have the type of contracts with these thermal power producers where, because these are huge investments, you must remember. For example, it may be in the terms of $300 million or $250 million. A power plant in a 250 megawatt to 200 megawatt, 300 megawatt size will be in that range. $300 million, $250 million. So these are huge investments. So their investment is guaranteed in one way because the power purchase agreement is given a sovereign guarantee by the Sri Lankan government. The other thing is the contracts are made in such a way that whether they are dispatched or not, whether they make energy or not, if the power plant is available, their capital will be repaid. Capital plus a return on investment. Their generation is for pass-through. It is dependent on the amount of fuel they use and the amount of lubricants and the O&M, which is given in formulas. It is a pass-through cost. They are not supposed to make any profit. Of course, if they keep the plant more efficiently, because the efficiency is a given value. If they continue to if they improve their efficiency, that will be to their advantage. But on the other hand, they cannot make any profit on the generation. Their capital is repaid if they make the plant available throughout that 15-year or 10-year. Generally, it is a 15 or 20 years, but there have been 10-year contracts also. Those are the IPPs or the thermal power producers. The other ones, the NCRE, the non-conventional renewable energy, or the new renewable energy, other renewable energy, other energy. The major issue with them, you would remember, was that their intermittency. So with this intermittency, these power plants cannot be certain of giving the capacity, of making the plants available. So because of that, there is no capacity payment attached to them. And these, which we call the renewable energy, we have standardized power purchase agreements or standard power purchase agreements. We call them SPPA. The others are IPP. This is SPPA. SPPA is we pay for them for all similar plants. Previously, for all renewables, it was like the same price, but now it is depending on the technology, the price is different. But still, if you take all mini hydros which are contracted in the same year, they will have the same contract, same tariff, and the agreement is same for everyone. Only the annexes will change. The terms of the agreements are the same. That is why we call them standard power purchase agreement, and they will be paid for energy. And the tariff is set in such a way that their investment would be recovered in 15 years for the projected energy from that. The energy price is given in such a way. But if they don't produce that energy, they will not be paid. That is the difference between IPP contracts, what we call IPP contracts in Sri Lanka's context, and the SPP, the standard power. The IPPs have, or the thermal power plants have a unique contract for them, depending on their technology or the fuel and all the investment, all that, and also the lending rates that they use. But for the standard power purchase agreements, which govern the renewable energy below 10 megawatts, that is a standard power purchase agreement. If you are a wind plant connecting this year and the other one is also a wind plant connecting this year, you will have the same tariff. Whether you are a mini hydro, wind or whatever it is, the agreement terms are the same. It will only be the annexes which will be different because of the technology or the tariff. So those are the standard power purchase agreements. SLSCA, the Sustainable Energy Authority, was established to develop indigenous energy resources. So it has sort of a twofold scope. One is with regard to renewable energy, the other one is energy efficiency. Public Utilities Commission, the PUCSL, is the regulator of the power sector. You would know, like, you would have heard more about the telecom regulator, but I think now the PUCSL is also well known. The acts, these are, I don't want you to remember, I don't think you need necessarily to remember, but just this is a regulatory or a legal viewpoint of the sector. The major electricity act that prevailed in Sri Lanka was the Electricity Act of 1950, I can't remember the number, that was replaced in 2009 by the Electricity Act number 20. And there, for the first time, the regulator was recognized. Of course, the regulator had been established much before in 2002 by the PUCSL Act number 35 of 2002. The regulator was established, but it was not given powers. If you remember, you would remember that these are the years from 95 to 2006. That was the period of in the world also, from early 90s, for this reform of sectors, unbundling of sectors. You would know that the telecom sector was unbundled from a single utility to many utilities, and the regulator was introduced, and power was next to a certain extent. There was even a bill passed in the parliament. It became act, but it was not implemented for restructuring the sector, but it was restructured in 2009 with powers given to the PUCSL, the Utilities Regulator, the Utilities Commission, as the regulator to give license. And now the licensees are, the regulator is PUCSL, the policymaker is the ministry. CB is the only transmission licensee as per the Electricity Act 2009, and it was amended in 2013. CB is the transmission licensee. Generation licensees, there are many. CB has license because it has generation plants. IPPs, the thermal power plants which have contracts with CB, they should also have generation license. And even the SPPs, the small power, even the 100 kilowatt power plant which is connected to the CB system, should have a generation license, and the PUCSL issues. And distribution license, only 4 licensees, LECO plus CB. CB has 3 licenses issued for 3 geographical regions which are covered by 3 CB divisions. So that is the way the system is now running. There is the regulator, there is the policymaker, and CB is the single buyer. It is in the single buyer because in Sri Lanka nobody can purchase electricity for reselling except the transmission licensee. That is CB. If you are producing electricity and if you want to sell it, you can sell it only to CB. And according to the Electricity Act and its recent interpretations, CB has to go for competitive bidding to purchase them. We went through this. This is just the different type of technologies of generation. Sri Lanka has a very big mix of technologies, even though it's only 3,000 megawatts. Different fuels, different all kinds. So if you take diesel engines, there is furnace oil, residual oil, and auto diesel. Then there are combined cycles which are running on diesel, naphtha, and not only that, there is furnace oil fired combined cycles also. One private one, like that. Anyway, these are just for you. Okay, cost of production, I will not go into details, but one thing is when you are taking one of the major things in the power sector is planning for the future. Generation, cost of generation, investment, capital cost are very high. So how do you decide on having a plant? When you CB or whoever is making a generation plan will plan for the future, and they will find out, they will project the demand. What is the projected demand and how much can be met by existing plants? Of course, the demand will increase with the population increase or the GDP increase. With the people's needs increasing, the demand will increase. And if we have only the present power plants, some of them will be retiring, some of them will have their life end, and also there will be a deficit. So how will we cover this deficit? You will need new generation to come in. One way is energy efficiency. With that also you can cover up this deficiency, because if you improve the energy efficiency, the demand increase will be lesser. That is one thing that we have to do anyway. But we cannot do only that. We should have new plants coming out. So how do you make an investment decision? New plants decision. So that is basically an investment decision. Like any investment, you have to think about the capital cost as well as the O&M costs. And you must remember that line, that demand. Okay, as I said, we should have power plants which would be able to run this amount and this supply this. We should have power plants which should be able to run, it should be running 24 hours throughout. Then there are power plants which may not run at full load throughout. They will be running full load, they will be running 24 hours but with changing load. And we will need certain number of plants to only to work for 3 hours or maybe 2 hours. So how do we make that decision? For that, we should, I will not go into these cost details because the numbers are old. This was the numbers I have used here is from a 2015 plan. But anyway, the important thing is, for an investment decision, you need the capital cost and the variable cost. You have to think of both. Think in this sense. You need to buy a vehicle, and how would you decide on that? One thing is how much money you will have to spend on it, the capital investment, and the other is the running cost, that is the variable cost. If you are going to use this vehicle every day to run for about 100 kilometers or 50 kilometers, you will be using the highway and going to somewhere for 50 kilometers and coming back, and the 50 kilometers in the highway, maybe in half an hour you would go, so it is easy. But anyway, you will be making up about 100 kilometers a day and 2000 kilometers a year, month. And then you have the option of buying a diesel vehicle and a petrol vehicle. What would you do? You would go for the diesel vehicle, because it has even though it has a higher capital cost, it has a lower running cost, because but if you have only, if you are going to use it only per 1 week or once a month, or 1 week to go, once a week to go to Polar and once a month to take mother to the temple, so 5 times you are going to use it, but you need it definitely, otherwise you have to fine for taxis, and then you are running it for your operation cost would be low. So you will be using it for a very short time. Then what you would go for a petrol vehicle, because your running costs are low, because you will be, even though the running costs are high, because you will be using it less, because of the lower capital cost, you will go for a petrol vehicle. So similar kind of a decision you have to make when you are making investment decisions in the power sector. If you want to purchase a power plant which you will be running for 24 hours, full load or at an intermediate load, generally a full load, then that plant will generally be of a higher capital cost but of a low running cost, because generally the lower running cost plants like coal, LNG, that is gas or nuclear, have very low operation costs, so fuel cost, but the capital costs are higher. But because they will be running full time at full load or almost full load at a high plant factor, the higher capital cost will be overcome by the low fuel cost because it will be running full time. But for plants which you need for only a certain part of the time, you would use lower capital cost, higher running cost, because the running cost will be only few. So there you may buy a gas turbine. So that is what, from these figures, what the coal plant, when it has, now again these are just indicative figures. If the coal plant is 2000 megawatt, sorry, $2,000 per a kilowatt, the gas turbine would be 500. So this is 4 times high. And at these fuel prices, yes, the generation cost, that is the fuel cost for a coal is for this these fuel costs. This is the fuel cost. This is the generation cost per unit. Coal steam is 7.46. For gas turbine, it is 26.73. This one has at 80% plant factor. So this is not directly compatible. So I would, sorry. Here, this is the plant factor, that is the usage versus the unit cost. You would see that this gas turbine, sorry, the nuclear power plant at low plant factors has a very high power, but it is coming down. Here you would see that at 80% plant factor, these two, the supercritical coal plant and the blue one is the trick, I think, another coal plant. So these two coal plants are at a lower cost. The other plants are at a higher cost, even at a high plant factor. But at low plant factors, these power plants may be, this one is lower. So this could be a gas turbine. But I am trying to bring to your mind is that for lower plant factors you will need certain power plants, and for higher plant factors you would need different kind of power plants. That is the basis on which these selections are done. Tariffs I will not touch upon. Tariff is available in the CEP website. Cost of production, this is how this has changed. You would see in 2013, 2015, these are the wet years, renewables were there and CEP made a operational profit, but in other years, operational losses. The planned development is by the long-term generation plan. There are planned generation, and one thing that I would mention is that at present there are no thermal power or a base load plant in construction in Sri Lanka as of now. A base load plant, even if it is a gas-fired one, will take at least 5 years to be built. The plant that was to be built was the Trincomalee coal power plant. Unfortunately, just before the week of it was to be tendered last year, it was cancelled. So there are no base load power plants under construction in Sri Lanka as of now. So that is a tragic situation where we have gone back about 15 years back, when in the year 2000s, to the same type of power crisis that we are in. Of course, short-term measures can be taken, but the long-term issue will remain. All these power plants, Umawaya also, you know that there are issues, and Umaya's main purpose is irrigation, not hydropower. Broadlands, this is just a 35 megawatt power plant. Morogoro is just 27. And the only power plant that is in sight is this 300 megawatt Kerala PTA, which was, because of tender issues, you would have seen, was in the newspapers. And the Mana 100 megawatt, even if it is 100 megawatts in Mana, other than, I mean, when you take January and February, I think not more than 10 to 15 megawatts will come from this power. But it will give 100 megawatts during the monsoon time, when the monsoon winds are there. So the base load power plant is not coming. So that is the issue which is facing the Sri Lankan power sector. The transmission network, now I am running short of time. This is somewhere in 2022. Of course, the most current plan may be different from this, but still the principle is the same. You would see that there are it's a higher number of 220 lines. The 220 line is going even up to Vaunia, and it is coming to Hambantota also, and maybe right down to Gaul. 220 lines are increasing, and also 400 line has also been introduced, but that 400 line was introduced because there was going to be a lot of generation in port in Trincomalee. But now with the cancellation of power plant here, this will have to be reviewed. So this was based on having a large number of generation in this area. Anyway, you would see that there are more 132 lines and a concentration is increased. So what happens is, when the network is improving or enlarging, you will need a higher voltage to transfer. So that is why we are going to move to 220 and even maybe to 400 kV. Okay, key issues in the power sector. There are many issues. One is the delay in implementation of power projects. This is, I would say, the major issue. It is again recurrent. This we faced right from about 19. I think we have faced this right throughout, even though we remember only the last few years. I remember when I was in Lakshapana first serving, I remember one of the very senior or retired person saying that when one of the Lakshapana power station units were commissioned, it could not be taken out for other testing because there was a power crisis and the power plant had to be run throughout for 2 or 3 months. So because of our country, because of the economic conditions, we have these issues. But now that electricity sector, there is 99% electrification and the people are so dependent on it, it is very difficult, or it's very risky to have such crises. One of the things is cost, the high cost of production. The high cost of production comes because we have high cost power plants in operation, mainly the the oil power plants. The low cost ones are either coal, and if the next option is gas. Both needs a time for implementation. Coal of a typical coal plant takes 4 years to, starting from, it's a minimum 4 years to start from doing a feasibility study, funding. Of course, it generally takes about 10 years, but if you take on theoretical values, it takes 4 years, and construction 4 years. So it is 8 years to do a coal plant. That is why if you take today, at least it will take 8 years for the next coal plant to come, because there have been some mini feasibility done by the Japanese for a advanced supercritical or some kind of that thing in Trincomalee. If that materializes, maybe in about 6 or 7 years time we can have it. 6 years maybe we can have it, but otherwise for 8 years you need. Because of this, when there are issues coming out, you remember Puttalam and even Upper Kothmale, there were delays. When these base load power plants or power plants which are low cost gets delayed, anyway you only have the short term requirement, and when you have this short term requirement, only the oil power plants or the emergency power plants, the diesel power plants, that can be taken or implemented in a short time. So they are implemented, and at that period they have to use diesel or oil, and that costs much. So this will continue. This continues. This cycle was there even at early 2000s with the delay of the Norochole and Upper Kothmale, and we are now seeing it. Trincomalee cancelled and no base load power plant in sight. So that is a big issue in the power sector, because one of the reasons maybe is that with these base load power plants during a political regime's time or even a high official's time, start to finish these things do not happen. And logically, any policymaker or not a policymaker, anybody who is a politician or a official would be more interested in having something which he can do within his time. After that, he may not be sure. So that may be one of the reasons why these things are not getting. I mean, if you can't open this, what you are planning today, you may not have interest in that. But from a country's perspective, those are the things that one should have have plans, start implementation. When the base load power plants get delayed, you will have you need other plants. Then there is no option or power cuts. In Sri Lanka, we have decided that generally the policy has been that we will not have power cuts. We will have power at any cost. Whether that is correct also economically is something that has to be reviewed. But the previous government in the last 10 years, all governments have decided that no, we should not go for power cuts. We should have power at any cost. So this power sector, the high cost of production. With the introduction of coal, of course, the relative price of the relative cost to the country of electricity. Of course, your bill does not represent the cost because it is either subsidized or either you are charged at a very high rate. If you are using less than 120%, you are subsidized to a great extent because, as I said, it was the cost of the average cost was about 16 or 17 in that 18, I think, last year. But generally, people using more than 120 units are charged about 20. People who use more than 180 are charged at about average is 35 rupees per unit. It's a 45 after 180, but if you take all the units, it's somewhere around 35. So they are supposed to subsidize another part. But if you take the country's electricity bill, with the introduction of coal, it is less than what it would have been if it was oil. But if you remain at this point, again it will be oil that would be filling. And we must remember that renewable, yes, operation cost is less, but if you take the capital costs for all types of renewables, especially wind and solar, you have a very high percentage of capital cost which you have to put for utilize foreign exchange, and the capital cost we have to utilize at now itself. So there will be, and if you are bringing in wind power or solar power as we are doing now, none of those, neither solar PV panels or wind turbines are made here. About 90% of the costs of these plants are capital cost is from. So if you try to bring about 400 megawatts or 1000 megawatts of those plants, then there is a foreign exchange outflow for them because we will need a foreign loan. Even though it may be commercially brought, that will need a foreign exchange from the country. Long term wise, yes, there is advantage because there will be no fuel cost. But the current crisis may be aggravated. We don't know. We have to analyze. There is that part also. So it is not a black and white. With regard to power sector, you have to understand that there is no definite truth, there is no definite answer. All has the black and white. The coin has two sides. The financial losses of the sector, that is the CEB generally loses because the other surrounding entities somehow get paid, and it is mainly coming from, there is the high cost of production from this side, and from the other side is selling below cost, and the selling below cost because of social and political reasons. And this is also integrated because CEB of course will have to purchase fuel from CPC as well as pay to the independent power producers, the standard power producers. When CEB is trying to pay them, CEB will not have enough money come from this side to pay to CPC. So what will happen? Or pay to the IPPs because income is not matching the cost. So CEB will go to People's Bank and ask for an overdraft or an increase in overdraft and will pay to the IPPs. And to the petroleum, CEB cannot pay, and the petroleum is in a fix. It cannot order the next fuel required for CEB also. So it will go to Bank of Ceylon and get overdraft and put in the LC. So now 4 organizations, CEB, CPC, People's Bank, and People's Bank will also now be at a sort of a high risk because it is lending to a single organization. Bank of Ceylon is lending. Fortunately, the government have put the 2 organizations to 2 different banks. If this was put to the same bank, it would have been a further problem. But anyway, so these 4 are intermixed. Petroleum is having difficulty in meeting its ends, making its ends. CEB cannot pay its lenders. Petroleum cannot place its LCs. CEBs and People's Bank, Bank of Ceylon and People's Bank having its lending rating going up, so the rates, the lending levels going up. This is interlinked. And on the other hand, the cost of production is at a high level, even though it could be made lower. So these are interlinked, and the price is kept at a, even though the fuel or the cost are fluctuating, generally this is kept at, it is never, I mean, very rarely increased. So that affects the economy. So what is, but on the other hand, there is supposed to be a subsidized system. The higher users, they use higher amount of electricity because they can pay. That is the concept. And they are subsidizing the lower end of the customers because they cannot afford, but it is the duty of the country or of the people to give the opportunity for the others also. So that is another social value concept. One cannot say that is also wrong. I mean, that is why engineering and economics are all mixed up or integrated. You cannot take them apart. Maybe in other fields you could, but here you cannot. You have the social aspect. Doesn't the other people have a right to have the electricity? Now we have given them connections at 99%, even at the cost of the state, cost of CEB we have given them. Last year, I mean, CEB gave them loans to have their houses wired. To that extent, the government policy is there. And if they cannot pay at that rates, what is to be done? So the government may be right to having a lower tariff. But then who is paying the gap? And the people who are paying the gap is also coming down. If I have time, I will tell you in the next slide. Then conflict policies. There are conflicting policies regarding tax, and also two examples is net metering and net plus. Now net metering and net plus, you would know the solar rooftop schemes. Now they are on the face of it, and also in theoretical aspect and long term, yes, good, because they are renewables and they will set off the, I mean in the future, in a long term, to some extent the foreign exchange and the thermal dependency will come down. But on the other hand, you think of who is having net metering, who is having net plus. A person having an electricity usage of about more than 400 units. That is the investment, if you have done it for your house or for the others, you would know that. This is the sort of, what do you call it, the level where according to the developers or the marketeers, that is the usage. You should have around 10,000 rupees monthly bill. Then it is profitable for you to do that, to have solar net metering or solar rooftop other scheme. So what happens? From that scheme, the investment is done, of course, and from the consumer side, yes, you are getting a zero bill or something. If you may be consuming 10 to 20 units or 30 units, so 30 units at 250 plus the 50 rupees, you may be getting 100 rupees bill. Whereas before, you got a 6,000 rupees bill, or maybe, sorry, 10,000, 12,000 rupees. But remember that during the peak time, you are drawing on CB resources. You are consuming electricity. You are getting CB to run those plants at high operational costs. Why? But you sold that energy, or you gave the energy to CEB when it was not really needed. It may be needed, but not at the peak or the major requirement. CEB does not have any place to store it. So CEB has to not use it, may have not use its own resource, own generators, but use the electricity coming from you. Anyway, the result is the income for CEB has come down from 6,000, from 10,000 maybe to 100 rupees. And that 9,900 difference has to be made up, if possible, from this generation difference, because you have given electricity in the daytime and CEB has a generation mix changed in the daytime and again in the night time. But it is rarely that happens. So there is an issue now there. For a good intent, with a good policy, with a long time, environmental and other benefits, positive effects, we have implemented these schemes. But on the other hand, it is affecting the finances of the sector in a negative manner. So those are the conflicting issues in the power sector. In the power sector, there are many such examples which one can show. So those are another issue in the power sector. Then the integration of intermittent renewables, I will come up with that. Environmental and social issues at site locations. So this is another issue which is linked to the power plant delays, but not only to the power plant, but to transmission lines. And this is, I think, common to any infrastructure project now coming up in the world, and also in educated social, where educated people or the social level is high. As if there are people from RDA or even water board, we all may have faced, even the private sector, when we are trying to put up something in somewhere, there is a protest from one group or the other. And from their viewpoint, I am not saying that it's wrong, but these things have affected the implementation of infrastructure to a great extent in Sri Lanka. And the delays of infrastructure in a developed country and a Sri Lanka, or a country like Sri Lanka, the effect is different. In a developed country, it may have other resources, other ways, and the cost of the next option may be very low. But for us, it is very high. A delay of 1 year of a power plant, of a low cost power plant or a base load power plant, if it is replaced by thermal, by oil, is very high. So that is an important factor. This environmental and social issues, even to string up transmission lines, now it is very difficult. I will be going until 7:15 as we started at 5:15. Difficulty in implementation of tariff, which is, and also the poor public image of CEB. CEB, you know that in the electrical sector, the main player is CEB, but it does not have a very good public image, and that was one of the reasons why the last tariff increase could not be implemented. It had to be changed, if you remember, some years back. So those are also issues in the sector. Involvement of private investment. Now this is again a question all the time coming up. Having thermal, because the government is having difficulty in getting loans, because we have now improved our economic level close to 4,000. So now we are sort of a middle income country, and with that the concessionary financings are dwindling, and the agencies are giving for concessionary financing only for not for infrastructure, but for things like health and education, things like that, especially health. And the government also does not want to have its loan portfolio or commit itself for things like infrastructure, where the government can get loans, commercial loan, where the private sector can invest. And because of the existing IPPs and future investments also the government prefers now to have private sector investment. But when you have private infrastructure, the operating costs may be lower, but the profits will be going away, and also there are the issues of return. The returns required by the private sector, if you are investing for indirect investment, will be high, because they are not sure of our, even though they are signing for 20 years, they would want to make their returns maybe in 8 years or 10 years and think of the other if it comes okay, otherwise, because they are not sure of our social and the continuity of our economic conditions. Another issue which is interlinked, which has come up, I will just cut only for 5 minutes, but it is coming up, is the involvement in the power sector also of many institutions, and the decision making process and the responsibilities now are getting diluted. In addition to the organizations that I mentioned, there are the cabinet committees, and there are various agencies which are, and also the NGOs which gets involved in this decision making process. And if you take the government, there are many government. Now I am not saying that it's wrong, because when a country is getting developed, especially when it is educated, when its social level is improving, and the new liberal thinking is that there should be participatory decision making. So there is not a one single body. When previously CEB decided we need a power plant, consulted the minister, consulted the president, got approval, got the loan, built it up. But now it is not that way. There are so many organizations, but sometimes the decision making process gets delayed, and also sometimes it gets sort of diluted. Nobody is delayed there. So that is a major crisis, major issue in the power sector. And also the responsibilities between the PUCSL and the utility. who is responsible? The Act has given certain responsibilities to the Utilities Commission, certain responsibility to CEB. But now it has come even to the level where the CEB has had to question whether the PUCSL is right in its decision making. That certain decisions that it has taken with regard to the generation plan, CEB has written to the PUCSL challenging that the decisions it has taken is wrong, because the plans made by CEB for the future has been completely changed by the regulator, and the regulator is quoting a certain part of the Act. So it has now gone into the little legal interpretation. And anyway, if they take the outcome which will happen in 10 years time, for example, to make it very simple, when CEB is saying that in 2022 the cheapest is to have type A plant, PUCSL is saying type 2. So who is going to take the responsibility? Previously, if there was a power issue, CEB would be responsible. But now there are two organizations, and also there are other organizations which are taking in the government structure. There is a Parliamentary Consultative Committee. Now it has a new name, I think. So it is given more responsibility. That is the way of a developed country, or developing economy, or more liberalized country. But it is also diluting. Now there is a major issue in the sector where the PUCSL and the CEBs are at loggerheads. CEB has submitted a plan which was changed and approved by the regulator, and CEB is saying you can't change it. You may amend it, you may ask us to amend it, giving your reasons, your instructions, but you can't change it. But PUCSL is saying no, you have done it in a wrong way. We think what we are doing is correct, and we are doing it. Now what is the role of the regulator? What is the role of the utility? And now it has come into legal interpretations. So that is again the issue between the regulator, and the issues between the regulator and the utilities or the licensees have been there in other countries also. But in Sri Lanka now it has come to a very tricky, and also the involvement of many. We all know that when a decision is to be made, when there are many stakeholders, it is very difficult to make it. And also if you take a meeting when there are so many people and the minutes are taken, and after 2 or 3 meetings, and if this decision has failed, you cannot find out anybody who has said yes for that, or who was responsible for that. See, there is a similar thing in the power sector also. So that will, or it's only surfacing now, but that will also be a key issue. But that is not a fault of anybody, but that has to be avoided, because the thinking, the pattern of the government thinking is that there should not be, there should be more involvement of everybody in decision making process, starting from the people, which is correct. But on the other hand, when there are too many people, there is the saying, too many cooks spoil the broth. So that may be there. And also when there are two sort of strong organizations responsible for the same thing, the utility, the CEB is strong because it has a sort of a higher, because it has a historical evolution, as well as because it has more professionals or more people involved, and also more high turnover. And it has sort of, it's an established organization. On the other hand, the regulator has legal powers. It has been given powers by acts, even though it may be new organization, new entity. So there are different thinking patterns. So those are the things that is coming up very much in the sector. Renewable energy integration, of course, I basically touched upon it. The major issue is that with renewables is the intermittency. You cannot store. So you cannot compare having a 100 megawatt, even a high cost diesel plant, and a 100 megawatt wind plant are different. I am not saying one is better than the other. They are serving different purposes. And when you want to dispatch, or when we want to have a certainty of dispatching or certainty of usage, you have more advantage from a diesel or a oil or a coal or a major hydro plant. But when you have the issues of operating costs and also the foreign exchange issues, to some extent, you have advantage from the renewable. So you need an integration of both, and integration of renewables. There are technical issues also with this intermittency. We all know that. I mean, just in a sense, we would say that we are a good country for solar. Yes, and we will make calculations or things comparing maybe things in other countries. But in India, these prices and these technology, solar developments some have taken place in Rajasthan. Rajasthan is a fully desert, where the climate just does not change throughout the day or throughout the year. But if you take Sri Lanka, it is surrounded by the ocean, and you can have cloud changes within a day. So the solar patterns, or the solar megawatts, or the solar generation, within an hour, within 10 minutes, it can drop down when you have a dark cloud coming up. So there are things peculiar to our country also. So it is not a simple answer. So integration of renewables, because we have had conventional systems for a long time, for more than 100 years, now we need different technologies, different approaches. That needs time and that needs investment. So the investments for renewables also has a cost. Even though the operational costs are lower, sometimes, yes, there are many mini hydros, you would know that, which have not been held up because there is no grid connection. And you, for having 1 megawatt here, another 2 megawatt here, 500 kilowatt there, another place within about 25 square kilometers, maybe we are having 50, now it may not 50, maybe 20, but for 20 megawatts, you cannot have 33 kV lines all around connected because it's far from the grid substation. You will need a grid substation. But for 30 megawatts, to bring a grid substation to that point and a transmission line, that will have a huge investment. And for energy that you will not have continuous and not dispatchable. So there are the issues. So it is not a one-zero answer. That is what I want to point out. And also the renewables, this non-conventional renewable was taken in from, was purchased by CB for this standard power purchase agreements on feed-in tariff. That is for a standard tariff. But now the policy decision, it has started, especially for wind and solar, is that it is competitive bidding. So the wind power plants, the solar power plants are being bid. That is, the private investors now can bid and win tenders and construct power plants and supply to CEB. CEB is floating tenders. So that has improved the cost, to bring the cost down. At the start, it was to develop the industries a relatively high tariff. That is, cost reflective tariff was given on a first come first served basis. Now it has turned to competitive bidding. So that is the lecture. So I have covered it in 2 hours. I have about 5 minutes more, so people who are in urgency can go, but I will just touch upon these sources, because all these which have come are from, in my presentation, are from public documents. Nothing has come from a special CB document. So even for your exam, not only for energy lecture, this too, the National Atlas and the annual report of Central Bank. Now this is what I have been telling everybody. This is a very good document, report. This is about, I think, 300 or 400 pages, but I am not asking if you have time. Very good to go through it. But there is, at the start, there is a special chapter and there are some figures at the start which gives a summary report of the economy and also the statistical features of economic features and social figures. So economic figures gives out the GDP and all those things. So you can just have a glance through that and read through that first chapter. By first chapter, I mean there is a summary of the economy, not the detailed one. And there you will be surprised how much things that the central bank touches upon. And you should be proud that at least one organization in the country is still making a report like that. That has, if you think about your sector, any sector, it will be mentioned in a macro level. That is what one would expect from an organization like central bank, and they are doing that. So I should appreciate, we should appreciate, and that will give a lot of things for your this, not only for energy, for the whole, other than the ethics and that type of specific questions, to the whole range of questions, some support. the long-term generation expansion time. This is also public document, and these websites, the PUCSL, and this is the sustainable energy website. So these are good sources for you to go through, and just these things I don't want to repeat, but as this is something that I have heard from people who have dealt with your past papers, that it is important, because it is true that I mean, we have to all have to accept that the two issues. One is that these are not mathematics with which we are familiar, so we know that. So this is a different type. This is the first time maybe we are writing this type of analyzing answers, and you must realize that there is no specific answer for most of these questions. You will be asked to analyze whether this is correct. So you can say no or yes. Only thing is you have to give the arguments and write it in simple English. Don't try to go in, even though that we are engineers, but when we are trying to write in some other language, we sometimes forget where we started. So in short sentences, correct English and simple English, and finish the sentences that you started. What I mean is, try to go for short sentences, then it is easy for you. Legible handwriting is important. My handwriting also, I also can read, that is another thing. But because you are put paper, at least somebody has to read and give marks. So because you may have not written anything for a long time, you may have time. I mean, we may have written when we were in the school, but maybe in the last 5 years you may not have written a half sheet long document for a long time. So when you are writing, even you may have forgotten letters writing. That is why I would say that at least 4 question papers, write answers and give one answer to another, somebody to read and say one thing is to whether he can read it and whether he can understand it. I am not trying to dishearten you with 2 weeks to go, but you will find the other person will not, because we have not written. Now, because we have not written analytical type of questions for a long time, descriptive type questions. So that is another thing that I would advise you. I mean, it is not regarding energy. All other questions, just take some questions, not only discussion, not notes, but write answers. Then you will know how difficult it is. Okay, I have taken 2 hours and 5 minutes, and if there are any questions, of course I have taken your time. People can leave. If there are any questions, I will answer them. Thank you.